Welcome to lesson 3 of Vyper for beginners. And today we're going to cover hash maps. Hash maps are a data structure, just like how array is a data structure. We're going to take a look at what are hash maps, how we can use hash maps with our functions. We're going to look at a new data type called addresses and a global variable called message.sender that's available to us. Let's start with hash maps. So hash maps is often referred to also as a dictionary or key value pairs. So if you come from Python, you'll recognize a hash map as it works similar to a dictionary. So a hash map is a data structure that allows you to store data. And the way it does it is you have a key, and with that key, an associated value. So that key has a name. In this case, we've named our key day, and it has a value, and the value's name is number. And then we can store data for each key. Let's say Monday, have a corresponding value, in this case 1. It's the first day. So for Tuesday, it would be 2. For Wednesday, 3. A more common use case for using hash maps is storing the balance of a specific account. This is how we define a hash map inside Vyper. We need to give it a name, a visibility, and then we define the key and the value. So this is what an example looks like, where we have the name balances, a visibility of public, then we use the keyword hash map, and between square brackets, we say the key is an address and the value type is a uint56, which is an integer. Let's head over to our dev environment and start using hash maps. Again, if you want to code along, I've got a repo set up for you. You can go to the right lesson, and inside the lesson, you will have exercises and this repo that we're going to code right now. I'm going to head over to my terminal and open my code editor. Inside my code editor, I'm going to open up my terminal. And the first thing that I'm going to do is create my virtual environment. Now, if you want to know how to set up your dev environment, go back to lesson 0. Let's activate our virtual environment and install all the necessary packages. All right, I'm going to open up my site nav, go to the Ape folders, into contracts, and over here you have a set of contracts available for you as a reference. I'm going to create a new contract called myhash.vy, and we're going to start coding. Close my sidebar and close my terminal. And we always need to start with defining a version for Vyper. The first thing that I'm going to do is give my hash map a name. Let's call it week. It will be of type public. Then we go hash map. The key will be a string, and the value will be uint256. So we're basically gonna create this key value pair that you see over here on the left and populate it with data using Vyper. So first, what we're gonna do is add some data to our hash map. So I'm gonna type up x will be an external function, dev add days, and then we need to pass a day of type string, and then a value for that day, which will say value uint56. And then what we're gonna do is access our week, and then for the day, which will be day, it will have a value corresponding to what we pass. Save this. Now, before we can compile and deploy our contract, we need a .env with our environment variables. Again, if you want to know how I set up my dev environment, check out lesson 0. Create a new file called .env, copy everything here, paste it. The script that we will run will populate the information here automatically, except for the private key. We're going to open up our terminal, open a new terminal, and run Anvil. Scroll up, copy the private key, paste it over here, close our .env. In lesson 0, we've learned on how to install Foundry and spin up a local chain. Again, check out lesson 0. Now I'm going to come to my terminal, navigate to the Ape folder, and then run the command ape run scripts, deploy Anvil. I've got a custom script to deploy on Anvil. And then we need to specify the network, which is localhost port 8545, enter, and then we need to pick our contract, which is the 4th contract, my hash. Then I need to sign a transaction, unlock my account, and this will spin up my local UI. Over here, I can enter a day, let's call it Monday, and then we'll have a value of 1. And so that added to my data structure hash map a key with Monday and a value of 1. Now, because we defined our hash map as public, Vyper creates an automatic getter function, which means we can access the hash map. Over here, we can pass our key Monday, execute it, and we get a result of 1. Let's add another one called Tuesday, and we'll add 2, execute it, and then over here we'll pass Tuesday to get the corresponding value, and we get 2. Awesome, we've created our first hash map. Now, even though this is a great example of how a hash map works, in practice, most of the time you'll use a hash map to define a key value pair of balances and their amounts. In other words, you'll keep track of all the addresses and their balances for a specific smart contract. Before we do that, we need to dive into the type address. Now, we've covered data types, integers, and strings so far, and those seem straightforward. But within Vyper, we have access to another data type, called addresses. Addresses are used to specify the owner of a contract or to use the wallet address of an account owner inside a smart contract. So when you have an integer, you can expect something like 1 or 2, and with text you can have something like ABC. With a data type address, you'll see something like 0x322. And so this is an easy way for Vyper to understand, hey, when we define the data type address, this is the value that it's dealing with. Here's an example of how we define a variable that will have the value of an address. So it's a name, visibility, and then we pass the type. Now, something that you'll be using a lot for your smart contracts is something called message.sender. Message.sender is a predefined variable for you to use, and it contains the address of the user that is initiating the transaction. So let's say we call a function, then our address is stored in message.sender. This is usually used to identify the person that's initiating the transaction, or maybe to set the owner of the contract. For now, what you need to remember is inside this variable is the wallet address or account address of the user or smart contract that is initiating the transaction. Let's start using the address variable inside our contract. Let's start with a name. We'll call our user balances. It will be public, type hashmap. The type of the key will be an address, and the values that we will store will be amounts. So those are integers. So we'll say UN256. Save this, and let's create a function. Will be external to add an address with a balance to our mapping. And in this function, we'll use the message.sender as an address. So for the parameter, we just need an amount, which is a UN256. We'll access our hash map by going user balances and then equals amount and then equals amount. Now over here, we want to use message.sender. There are a couple of ways we can do that. You can go up here and say user address, define it as public and address. And inside our function, we'll say user address equals message.sender. And then over here, we pass it user address. Save this. Now let's deploy our smart contract. Okay, now let's open our terminal. I'm going to press the up arrow key to find my deploy command, run it. I will pick the fourth contract because it's called my hash, and I have an error. That is because I forgot to add the self keyword here, because we need to tell Vyper we want to access user address inside this contract. Open my terminal again, up arrow, run the command, pick my contract, and I've forgotten the self keyword. Open my terminal again, run the command again, and then I've got another error, which is here. As a parameter, I said underscore amount, and I passed amount, so let's do that again. Run our command again, contract, awesome, it's compiled, we sign a transaction, unlock our account, and now we have our UI. So over here, what we can do is we can add a balance, and what will happen is we're not passing an address because we're initiating the transaction, so it's grabbing our address. So let's say our balance is 100, execute it, transaction is executed. Now, if I want to fetch the user balance, I'll need to pass my user address. So over here, I can click user address, and this has the user address of the message sender. I can copy this, paste it over here, execute it, and I can see a result of 100. Awesome. Awesome. So now we have a hash map that keeps track of balances per address, and we have a function to add an amount for a balance for the message sender. We could also create a function that adds a balance for a specific wallet address. So in this case, we would say wallet of type address, and then we pass an amount of type UINT256, and then self user balances, and then we pass wallet, and the amount will be equal to amount. Save this, open my terminal, press the up arrow, run my script, pick my contract, and I've used a name for my function that already exists, and we're not allowed to do that. So I'm just going to add the name custom, save it, open my terminal, run the command again, pick my contract, sign my transaction, unlock my account, and we've got our UI over here. So over here, we now have our function add balance custom. Now for our wallet address, what I'm going to do is head back to my terminal, go to the terminal where Anvil is running, scroll up, and over here, I've got a bunch of wallet addresses. I'm just going to copy one here, go back to my UI, paste it, and I'll put an amount of 100. Execute it. Now if I go down and want to fetch the balance, I will paste the address here again, execute it, boom, I can see the 100. So if you want to try another wallet, we can copy it here, add the wallet address, and we'll say 250, execute the transaction, scroll down, paste the address, execute it, and we can see 250. So now we have a custom function where we can pass an address and a corresponding balance. Now, if you come from Solidity, you might be wondering why it's called hash map and not just a map, and that has to do with how the keys are treated inside a hash map, but we won't dive into that right now. We'll dive into that in the future lessons. Awesome, congratulations. You now know what a hash map is, how to use hash maps with functions, what the data type address is, and specifically how to use message.sender. In the next lesson, we're going to combine how to use hash maps with arrays. See you in the next one. Now go and code some Python.